In this video, we're going to use the method of Lagrange multipliers to find the dimensions of a box open at the top, where the volume of the box has to be 4 cubic centimeters, and it requires the least amount of material for its construction. I find that the biggest mistakes my students make is that they never understand which of the two functions is f and which in them is g. So where is the constraint and which function are we trying to maximize or minimize? So remember that the function f is your objective function. That's the one that you're trying to maximize or minimize. So when you read the question, what is it that you need to maximize or minimize? Well, you can see that this is going to be the least amount of material, right? So you are trying to minimize the amount of material. And the volume is not your function f. The volume, the fact that the volume is 4, that's your constraint. That's going to go into part B. So that's what people don't understand. And it's really usually half of my students, 50% of them will say that it's the other one. Okay, so anyway, so what's my function f? F is the surface area. How do I find the surface area of the box? Now, here you have to worry about the fact that it's open at the top. So that means that you only have the bottom. You don't have the top. So the area of the bottom is x times y. That's the surface area, plus the two sides are y and z, right? Right and left, y times z. And because there are two of them, there will be 2yz. Okay, so okay, my highlighters are not working. Hold on, let me open them again. And okay, so now it's working. Okay, so this is going to be like this side and the left side. And then also you're going to have the front and the back. So that would be like xz, right? So here, this, I don't know if you can see it, but whatever. So the front and the back. The area of the front, that's x times z, and then the area of the back is the same, so that's 2xz. Okay, so there is your objective function. Now, if the top was there, then this would also have been 2xy, but because there's no top, it's just xy. And then the constraint is that the volume equals 4. So what is the volume of a rectangular box? Well, that's just x times y times z, right? Length times width times height. So that has to be 4. Now, they do want me to rewrite this so that 4 is on the other side. So this is going to be x, y, z minus 4, and that'll be equal to 0. Okay, so the method of Lagrange multipliers says that the gradient of f and the gradient of g should be proportionate to each other. All right, so what is gradient of f? So let's look at each term separately. Remember, when you take the derivative with respect to x, the other variable is just a number. So when it's yx, y is a number, so it's like 5x is 5, right? So yx will be y plus 2yz does not have an x and it's added, so that's just going to be 0. And 2xz with respect to x is 2z because 2 and z are both numbers, right? So it's like number x. Okay, similarly with respect to y, we're going to have x from the first term plus 2z from the second term and nothing from the last term because that doesn't have a y. Finally, z, so that's just going to be 2y plus 2x. Okay, so that's gradient of f. What is the gradient of the constraint? So x, y, z, derivative with respect to x. So both y and z are just numbers. So we keep them. And so this is going to be yz. Similar argument will show that that's xz, and then this is xy. Okay, so now we are going to set up the proportion, which is dividing the gradient of f by the gradient of g. Now, you might be worried and say, well, when you're dividing, aren't you not considering the possibility that whatever you're dividing by could be 0 and then you are in trouble? Well, that would have been true if this was not an application problem, but this is an application problem. Your box is not going to have 0 width or length or height. That's not going to happen. So these x, y, z are positive numbers, so you do not have to worry about dividing by 0. So we're just going to have to, what we do is we're going to solve this proportion. So let's look at the first and the second term. Let's cross multiply. So I am multiplying here this numerator by denominator of this guy, and numerator here by denominator here. And then I'm just going to do this in my head. So distributed xz. So I get xyz plus 2xz squared equals xyz plus 2yz squared. So now if I subtract xyz from both sides, you can see that this is going to cancel out. And then I will just say, okay, 2xz squared equals 2yz squared. And because again, x and y and z are all positive numbers, you do not have to worry about division by 0. This just means that y equals x. So we just expressed y in terms of x. Now what we want is also look at the first and the third fraction and set up the proportion there. Why third? Well, because we want to express everything in terms of x. So now we want to express z in terms of x. So let's see how that's going to work out. So we want also this one times that one. Okay, so let's go ahead and do that. So we get xy squared plus 2xyz equals 2y squared z plus 2xyz. So this plus 2xyz you can just cancel out by subtracting it. And then xy squared should be equal to 2y squared z. So what can be canceled out? So it looks like y squared can be canceled on both sides, and then z will just be x divided by 2. So now that I expressed y in terms of x and z in terms of x, I must go back to the constraint. Remember, the constraint was that the volume had to be 4. So what that means is the volume, which is xyz, should be 4. Let's substitute y, which was just x, and z, which was x over 2. And we got x cubed equal to 8, which just means that x equals cube root of 8, which is 2. Okay, so the dimensions of the box are 2 for x, 2 for y, because y was x, and z is x over 2. So 2 over 2, that's 1. So I think that would be it.